The table shows three values of x and their corresponding values of y, where y equals f of x plus 4 and f is a quadratic function. What is the y-coordinate of the y-intercept of the graph of y equals f of x? Okay, so a little bit of information to unpack here. This table that we're given is the table of the function f of x plus 4. That means we had an original function called f of x somewhere, and then we shifted it up 4 places. Remember, plus 4 means shifting it up 4 places. So this graph has already been shifted. This table gives us the points of the graph after it's been shifted up 4 places. Now, when you look at the question again, it's asking for the y-coordinate of the y-intercept of the original graph. So we're not looking for the y-intercept of this graph. We're looking for the original. What does that mean? We have to undo this shift up 4 places by moving this graph down 4 places. To move the graph down, it means the y values are going to be less by 4. So subtract 4 from each of these. And the new table is 21, negative 4, 23. I'm sorry, 21, negative 12, because negative 8 minus 4. 23, 4, and 25, negative 12. So these are the values of the original graph, the graph of f of x. And these are the ones we need to actually use to graph the equation so that we can read off the y-intercept, which it's going to be 0, comma, some y value. We're looking for the y value in that y-intercept. So to best do this, let's just use Desmos to model a quadratic regression. Let's go for it. So here we are in Desmos. Remember, to create a table, just type in the word table and the table pops up and populate it with your data. I've already done that. So now the next thing is to click on these little dots to add the regression. Recall this is a quadratic regression, so we'll choose quadratic regression, of course. And then we're going to copy this equation and paste it. You can see the y-intercept of this graph. However, there's a shortcut. If the equation is in standard form, the last digit here is the y-coordinate of your y-intercept. But to prove it to you, let's just look at the graph. We might have to scroll down pretty far down because you can see this is negative 2,112. So I'm going to zoom out so we can get there quicker. Somewhere around here. Just bear with me, and right in here you will see it. This right here. If I click on this, you'll notice that that's 0, comma, negative 2112. And we know that that's the y-intercept because it's known at the y-intercept x must be 0. Long story short, the answer to this is negative 2112. But if you remember that shortcut, just look at the last digit. That's the y-coordinate of the y-intercept. That's it.